This recording, we're going to cover percent composition, empirical formula, and molecular formula. And actually, this section of the chapter is relatively straightforward, so I think you're going to find it's easy to follow. There's just a few steps that you need to consider when you're solving these kind of problems. So when you're looking at percent mass of an element, notice that you're looking at the mass of the element, and it's divided by the mass of the compound. So make sure that you get the total mass, and you do that by going to the periodic table, and you want to add up all the different elements with their subscripts considered, and then you're just putting in the numerator the mass of the element. And once you have that fraction, you just multiply it by 100. So an example of this would be you have 16 grams. Oops, sorry. 16 grams. You're going to divide it by the total mass, and you're going to multiply that by 100. Sorry, my tablet's giving me a hard time here. And the answer is 44%. Sorry, that's a percent there. Okay, so percent of mass of each element in a compound is percent composition. So that one was percent of oxygen in that compound. Now, you're going to find that you have to do more than 1% by mass. If you have two elements in a compound, you're going to have 2% by mass. If you have three elements in a compound, you're going to have 3% by masses. Okay, here we have sodium hydrogen carbonate. Okay, so notice there's a total of 1, 2, 3, 4 different elements. So you're going to have 4% by mass. So you're going to total up sodium, hydrogen, carbon, and 3 oxygen to give you the total mass. And then you're going to take each individual element and you're going to divide it by that total. Now look at oxygen. You have to be careful here. You're not dividing 16 grams by the total. Notice there's 3 oxygen, so you want to add up those 3 oxygen and then divide by the total. So please be careful when you're doing percent by mass. You don't want to just take the mass of one element if there is a subscript of a 3, okay? And if you add up all the percents, they should equal 100. If they don't, you probably did something wrong and you want to double check your answer. So this is a good way to check whether or not you did it correctly. Okay, here's sucrose. So you need to find the percent composition. Once again, we have 3 different elements, so we're going to have 3% by mass. And notice we have 12 carbons, we have 22 hydrogens, and we have 11 oxygens. Okay, so after you find the molar mass of adding up 12 carbons, 22 hydrogen, and 11 oxygens for the total, notice that each element, you have to also look at their individual subscripts, and that's going to be part of the numerator. And when you add up all 3, you should get 100%. Okay, that was percent by mass. Now here's empirical formula. Now empirical formula, and I think I hinted at it when we were doing the lab, it's the smallest whole number ratio. So empirical formula, you're going to find out, could be different than molecular formula. So I think I showed you glucose. Glucose has a different empirical formula than the whole number, not whole number, but it has the different formula than molecular formula. And we're going to talk about that in a little bit. And if you look at the bottom here, okay, molecular formula of hydrogen peroxide, which is H2O2, the empirical formula is HO. So if you took H2O2 and you divided it by 2, reduce it down to HO, notice that the empirical formula is half the molecular formula. And I think the example I showed you in class, glucose, the empirical formula is 1/6 of the molecular formula. Now, notice I put at the top here, you can calculate the empirical formula from the percent mass, and you can assume you have 100 grams of a compound. I'm going to show you an example of this using educreation, so don't worry if it seems a little confusing right now. Please remember that molecular formula, it actually is the number of molecules, the number of atoms that are connected to each other but with covalent bonding in a molecule. So empirical formula is sometimes a fraction of that total. And the important thing to note is the molecular formula is always going to be a whole number multiple, okay? So there's no fractions that are part of the molecular formula. And when we do some problems, you'll see why I say that. Okay, here's an example where propane is a hydrocarbon and it has only carbon and hydrogen. Now they give you percent, so they say 81.82 and they say 18.18, and they want to know what is the empirical formula. Well, you can, like I said, you could take that percentage and turn it into grams. So instead of 81.82%, we're putting that into grams. And notice that we're dividing it by the molar mass of carbon. And here we have hydrogen, and instead of percent, we changed it to grams, and we're dividing it by the molar mass of hydrogen. Now, you're converting grams to mole, and that should sound familiar. Now, when we're looking at empirical formula, what we're looking for is the lowest amount of moles. So in this situation, the 6.812 is the lowest amount of moles. And what we're going to do, and you'll see this in a second here, is we're going to take each molar amount and divide it by the lowest amount, because we're looking for a whole number. And notice if you take 6.812 and divide it by itself, you're going to get 1. And here we have the 18.035 moles divided by the lowest amount of moles. And we're not getting a whole number ratio. So we have to do something to make that a whole number ratio. If you had to guess, what do you think you're going to do? Okay, we have to do something. We have to multiply it by multiple. And here we multiply it by 3. Now, please remember, you may not get exactly 3. It may be close to 3. So it may be like 1/10 of a way from 3. But it's close enough that the correct empirical formula would be C3H8 if you multiplied 1 by 3 and 2.6 by 3. Okay, here's methyl acetate. So here you have to figure out empirical formula. So please remember, the first step is you take those percents and you change them to mass. So here we go. And once we do that, we're dividing it by the molar mass to get moles. And what you want to do is you want to look for the lowest amount of moles out of those 3. And you're going to take each molar amount and divide it by that mole to get the ratio. So here we go. We're continuing on. We're taking the moles of each, and we're dividing by the lowest amount. And here we go. We don't have a whole number ratio. So once again, we need to do something with the numbers in order to get the correct ratio. So since carbon is 1.5 and hydrogen is 3, oxygen is 1, we luckily just have to double it. And when we double it, we get a whole number ratio, and that becomes the empirical formula. Okay, here's aspirin. So once again, you want to analyze it. You want to take the percent and you want to change them to grams. And then with each grams, you want to convert that to moles. After you convert it to moles, you want to look for the lowest amount of moles, and you're going to divide each mole by that lowest amount of moles to get a number. Now, if it's not a whole number, you may have to double it, you may have to triple it, depending, to get the whole number ratio for each. Oops, sorry, I went too fast. So once again, this is the lowest amount of moles. So we're going to take each molar amount and divide it by that lowest amount of moles. And when we do that, we get 2.2, 1.9, and 1. And unfortunately, it's not a whole number. So instead of doubling and tripling it, we're quadrupling it. So when we do that, we get a whole number ratio of C9H8O4. Okay, this one, I think I'm going to do it in EduCreations, so you'll see an email about me doing it in EduCreations. So I'm just going to skip this right now. Now, here we go. We want to find the molecular formula, and this problem, I think I'm going to do this one also on EduCreations. So the good thing is with molecular formula, the first step is you want to find the empirical formula. Now notice they've given you some additional information. They've told you that the molar mass of the compound, and this is something that has to be given, and it's usually determined in the lab. They tell you the molar mass of the compound. So what you're going to do is you're going to take the empirical formula and you're going to compare it to that next bit of information to determine whether or not the empirical formula is the same as the molecular formula. Okay, here we have vitamin D. They give you the percentages, the mass percents, and then they give you the additional bit of information, which is the molar mass, and that was determined by the lab. This has to be given to you in order to determine if the empirical formula is the same as the molecular formula. So once again, we do the same thing that we did with the empirical formulas. Notice that you want to divide each molar amount by the smallest mole. Okay, and when we do that, and this is a big molecule, we get 27 carbon, 44 hydrogen, 1 oxygen. So we don't have to multiply those numbers by a factor because they're all whole numbers. And the empirical formula for vitamin D is C27H44, 1 oxygen. Now that molar mass is 384 grams. So if you went to the periodic table and you added up all those different elements, you get 384 grams. Here, if we take the 384 grams and we compare it to what we found in the lab, it's equal to 1. So that means it's the same formula. Okay, what I'm going to do now is I'm going to stop this recording. I'm going to send you some EduCreations to help you answer the worksheet that I have requested for tomorrow's class.